please next presenter Woo-Joo Kim for the estimation of fracture toughness of metallic material by using instrumented flat ends shaped indentation test.
Thank you, ladies and gentlemen. My name is Woo-Joo Kim from Seoul National University from South Korea. Today, I am going to have a presentation about our project, estimation of fracture toughness of metallic material by using instrumented indentation test. And this is the contents of this presentation. So as we know, the fracture toughness is important properties for structural integrity assessment and product reliability, but the fracture toughness test has complex testing procedure, and it is a destructive method, so it cannot apply to the in-service structures. But instrumented indentation test with the simple loading and unloading curves, and we can get hardness and elastic modulus or various mechanical properties. And the most advantage point is the machine can be applied to the in-service structures with a simple procedure. So this is the motivation of this project. Actually, the managers of nuclear facilities and gas oil pipelines in government, they want to know the in-structure state. And main purpose of this project was to adopt the surveillance specimen in nuclear power plant due to the life extension issue and lack of the numbers of surveillance specimen. However, this approach is not the first one. Actually, there was the indentation cracking method with the Vickers indenter on glasses. With the Vickers indentation test, the cracks occurs in the plate, and they measure the crack length and calculate the fracture toughness. But this method is only for ceramic materials, which means they're very low fracture toughness value. So we tried to test it several times with a variety type of indenters. So when we tried to find the similar point between fracture toughness test and instrumented indentation test. And finally, we decided to the flat end shaped indenter with the 100 micrometer diameter. Yeah. And so why we choose the flat end shaped indenter? The first one is the constraint situation. We know there is the plastic zone occurs, which is surrounded by the elastic parts ahead of the crack tips. And the same as the indentation test, there are plastic zone occurs during the indentation surrounded by the elastic zones. And also, if we use the flat end shaped indenter, then we can observe the similar singularity at the edge of the indenter. So from these similar points, we thought that we can find a similar mechanics state between two tests. Moreover, more researchers analyzed still stress field beneath the indenter in terms of fracture toughness mechanics, and they reported that both two analogies are not perfectly same, but it is somehow a similar state will occur during the indentation. So here is our idea. So we did the flat punch indenter test and assumed the material is the isotropic, then the compression state is the same with the tension state. Then we can imagine the virtual crack line in here, and then we can state the state is similar with the cracked round bar fracture toughness specimen. So here is more the concept. So we assume that flat punch indentation can be thought as a cracked round bar specimen fracture test. So from this flat punch low depth curve can calculate the fracture toughness value. But still, we have two big obstacles in the indentation test. So one is the size effect. We know the fracture toughness value should be validated with the thickness condition. And also indentation curve is also varied according to the indental size. To overcome this barrier, we use the normalization. So as you see in the left picture, the indental size are larger than the indentation curve going to the upper. But if we normalize it with the indental size, we can get a mean pressure and penetration depth H or an indental size A curve. And then finally, if we reset the another indental size, meaning virtual indental size A prime, then we can converting to the indentation curve with A prime. So from this calculation, we don't have to test several different size of indental taste. But still, we don't know the correct initiation point, especially indentation. There was no pop-ins, even if we use the larger indental size. So, and since in ductile and brittle fracture behavior is quite different, so we finally decided to separate the two models, brittle fracture behavior model and ductile fracture behavior model. So first one is the ductile fracture model. So in this case, we adapted previous researchers' theory in cracked round bar specimen. They said the correct initiation point is at the maximum load in load displacement curve, and maximum load can be evaluated by limit load equations below the such equation. So experimentally observation, so correct initiation point in cracked round bar is the onset of fully plastic on ligament, and that point is calculated by limit load, and so we can determine the limit load point in normalization curves. But still we need to determine the size of indentor. So in this case, we adapted the experimental point of view. When we determine the J1C, the standard suggests a 0.2 millimeter blunting line, which means the 0.2 millimeter cracks are ignored. So geometrical similarity from this geometrical similarity, if we penetrate 0.2 millimeter, then it can be thought that the blunting crack is 0.2 millimeter. So we focused on the penetration depth H star as a 0.2 millimeter. Then we test with the 250 micrometer radius indentor and normalization it, and set the limit load as a correct initiation point. And after that, we know the H of A point and recalculate with H star 0.2 millimeter, and we can get a A star virtual indentor radius and indentation curve. And brittle fracture model is more simple. We approach this model as a testing phenomenon. In cracked round bar test, relatively low fracture toughness value of materials, correct initiation point is onset of nonlinear behavior. So in this point, we approached with engineering point of view. So we used the 0.2% offset line like a tensile test. So we found the correct initiation point with the intersection point in two lines. And also in this case, we determine the indental size with the 1T thickness specimen from standard. This is controversial, but usually we use the 1T thickness specimen for brittle material. So in case of cracked round bar, the thickness is the circumference in round tensile specimen. Then finally, we determine the A star as the 4 millimeters, like as a validated radius indentor. Same as the procedure in ductile model. So we tested with the 250 micrometer indentors and normalization it, find the intersection with the 0.2% offset line, and that is the correct initiation point. And we got a A-star 4 millimeter size virtual indentation size curve, and then calculate the fracture toughness. So here is the experimental verification. So we had indentation test by AI 3000 Frontix, and tensor and fracture test was done by Strong. Here was the reference data. We got a KJ's value because main purpose was to depth in surveillance specimen. We tested J-test and calculate KJC. And this is the Brittle model result. There are some good results, but some others. And this is Ductile model. We use the API still or SUS and so on, but some are different, some are good reason. And actually this is the positive result because we tested several more times and some results are very ugly. But this is for this data is for presentations till we have to develop more model more precisely. An application, last year we set up the low temperature indentation and chamber system to test it on low temperature. And Korea Atomic Energy Institution provided us the a special specimen for us, and which was used in the master curve method. So data were right side over there, but unfortunately there was no transition behavior in indentation test. But we try to find a T0 as a ductile brittle transition temperature. And future works remain to verify the model. We have to develop more price data, so we are making now thermal embrittlement material like a CF8M, and low temperature fracture tests need to be more. And also to find the criteria, because we have two separated models, so we want to unify it, or we want to find out the material state, ductile fracture behavior or brittle fracture behavior. So we needed the criterion. And also, this is the instrument indentation test is actually non-destructive method. So it is really hard to match with the fracture toughness value. And sometimes it doesn't make sense, I think. So need to more theoretical background. And long-term project, we have to test on neutron irradiated specimen for a surveillance specimen. This is another story of our project, and we are developing the indentation impact machine. And we want to make a correlationship with the CVN energy, but it's still ongoing. The project is still ongoing. And yes, the project is done. Thank you very much.
Thank you.